Okay, hello, my name is Mariusz Nowak. I'm web developer for about 12 years. For about, I'd say, 9 years, working with JavaScript as my main language. Currently, I work for Untitled. We are on a mission of delivering like a registration system, which is meant to be composable, extensible system that to be deployed in some developing countries. So citizens of those countries can register their business online, and technically developers from those countries should just take the system even without our consent, and to be able to configure such system for their needs. So today I'm going to talk about JavaScript dynamic type system. It will be very like bare to the bones presentation about like JavaScript language, even ECMAScript really. Okay, so maybe, yeah, let's start. Okay, I think the good way to organize the JavaScript values, if we'd like to see that main groups, will be these three main groups. There will be like primitives and object, but within primitive there are also two distinct groups like non-values and values. Do you have an idea? I'm not yet expecting any answer, but you can just now think, what do you think goes into those values? So maybe let's start with primitive non-value. So what do you think, which JavaScript values we will put there? That's good? Yes. Anything else? No. No, none actually is a type of number. It's actually a number value. It represents actually some value, although it says it's not a number. But technically, null and undefined represents non-value. Like, yes. So how would we characterize those things? They don't have any properties of methods for sure. And other thing that makes them distinct from the other primitives is what? What do you think? I don't think it's a good way to put it. I think the best way to put it, they don't have any alternative object representation. Any other primitives have this. Null and undefined, they don't have this. Okay, so what will happen if I will try to do something like this with non-value? Like assign some property, for those who don't see. If I would take non-value and let's try to assign like foo property and a value to it, what happens? Sorry? Yes, exactly, there's an exception. Yeah, and same if we'll try to access anything. Okay, yeah, you're ready to answer two questions or even more. Okay, sorry. Yes, and same happens if we just try to access any other value, but yes, set value is also about accessing a value. So now there's a question, why JavaScript has two values that represent lack of value? Do you have any idea? Yes? I mean, maybe if you want to go with microphone over there.
Null is some kind of value when you want to say there is no value, like the value is empty, and the undefined is like there is no value, there is no key, there is nothing.
Yes, very good, very good. It's exactly what's the meaning. I mean, technically, it's important to point that JavaScript, contrary to most of other languages, won't crash if you try to access any property on some kind of object. Yeah, if you try to say it will just return to you undefined. If you pass if you don't pass arguments to the function which was defined to have arguments, it also the system, the application doesn't crash. Of course, unless there's some validation there, but it's the other subject. They just pass undefined in that. So a null is to distinct those like happen to be no values from intentional values. So null is a representation of when we want to intentionally say that there's no value in that property. Yeah. So, and I'd say it's also good practice to use them that way. So never I would use undefined to assign to some property. Technically, you should always use null. And when you technically to reach the undefined is via deletion. If you want to delete the property, this is the way to kind of expose undefined. Okay, let's move further. So now let's talk about other primitive values. So what JavaScript values go into that bucket? Anyone? I heard number, that's numbers, that's good.
Numbers, Boolean.
Great.
Not a number.
Not a number, it's a number actually. It's a type of number. It's from the number group, although it's to say I'm not a number, it is a number, yeah? Yeah, booleans, numbers, what else? Strings, correct. Is there anything else? Very good, symbol, yes. Symbol is new. So for some, not all of you may be familiar with it, but because it came with the past year, yeah, specification. Yes, okay. So now, how would we characterize them? Similarly as null and undefined, technically they don't have properties and methods, but there's some very important difference between null and undefined. Okay, maybe I'll go. They have alternative object representation. And it's how it also goes to. It goes to they are also prototype based via implied auto-boxing. I will explain it on the other slide because technically we can access properties on primitives, yes, although the primitives don't have properties or methods. So let's go how it happens. So yeah, so this is how we access the value in primitives. What will happen in that third line if I just access an existent property on this kind of value?
Undefined.
Very good. You can take a... Very good, yes, that's correct. And what will happen here? Like I'm trying to assign something to the primitive, to some property, and what will be the effect? Very good, yes, there's no effect of this. And why it happens like that? It happens because implementation, when you do this, behind the scenes, kind of creates an object wrapper of this, and that way returns you property or method of that object. And that object is something else. You know that when you do new string, you get the object really representation of the primitive. It's not really primitive, but it's an object. So this is how what go. It's called like auto-boxing. So this may seem very non-optimal when you think of it. Oh my God, the object is created whenever I try to access. It's how it's specified that way, but it doesn't mean that implementation below exactly creates object in Polish memory. They have their ways to do it efficient. This is how it's specified to behave. So that's why you can see that any access is fine, and any try to set up some property will technically have no effect. Yes. So that's how it works. That's property access works on these primitive values. Okay. So now third group and last one, objects. So what values go into that group? Well, I'd say that easiest way is to say it's like this. Because if we will now try to mention every native type, I think it's no point, yeah? So everything else. So objects, yeah, clearly have properties or methods. They are prototype based, and they can also serve as a prototype for other objects. So they are like extensible. So this just for reference, I'm just showing, yeah, something obvious that you can assign properties, it has an effect, and that you can use an object to be a prototype of something else. Okay. Okay, so now let's talk about this. We mentioned those three groups, and let's talk about the detection. So how would you detect in your code is the value of one of the non-values? Like how do you do this? Technically, you have two values, so it's simple, yeah? But usually, how you are doing this?
If value. If value.
Sorry?
So I just type if value.
If value, no, that won't work because it also will catch the false values like false, zero, and we are speaking about non-values, primitive non-values, just null and undefined strictly.
We can compare to null with double.
Yes,
equals.
that's a good answer. So this is like short, and this is actually the only the only case where using the double equality operable is kind of justified. Because this will match strictly null and undefined. In our code, it's simpler to write this instead of 3 equals null or 3 equals undefined. So that's a good. And this kind of check is used very often in the internals of the JavaScript, and usually in APIs you also check it quite often. So this is a very common function for type checking. and the other. I skipped the second one on purpose. So how would you detect if some value is an object? So from the third group.
Equal constructor object and inside value is equal to that value.
Constructor object again.
So object function and with value as argument.
Yes, that's
It's equal to value.
and whether it's the same value. Yeah, that will work. Still, I would say this is a slightly dirty thing because it technically creates a new object in case you don't provide that value. So there's some side effect that you create some to be garbaged objects just to check if something is an object. So what would be the cleaner way?
Maybe if value is truthy and type of value is object, because null returns.
That's
type
very
of null
good,
returns,
but
object.
Okay, so it was that if it's truthy and if it's type of object. Yes, that was it.
Yes.
So that's not enough. That will cover some object value, but not all of them.
I'm kind of guessing here. Has a prototype?
No, but how would you check that it has a prototype?
Type of prototype is not undefined, for example.
But how would you access the prototype of an object?
Told you I was guessing.
Sorry?
Told you I was guessing.
Okay, so no.
Okay, first thing is to check if it's type of object, yeah, and second one is to if type of function, yeah.
Yeah, that's correct. That covers all objects. So yeah, here I intentionally just excluded null case because we have this not great behavior in the language that null also is type of object, so we need to exclude this. But this gives you the answer whether the value is an object. What's interesting, do you know there's a one, I'm not sure, should I know? Maybe I'll start with the next slide, so forgive me. Now about the second group I mentioned, usually there are no use cases to check whether something is primitive value, because in most cases we are either interested whether something is not a value, is not non a value, or if it's an object. That's the usual cases in the language. So we don't deal with, I don't know, is primitive value. That's not needed really. Okay, so now I'm gonna go to the type coercion and DAG typing, and this is the concept that plays extensive role in internals. All native functions work thoroughly through type coercion and DAG typing when they take arguments or contexts. This is not perfectly reflected usually in userland libraries, but I think that understanding of those mechanisms, acknowledging them is very important to be really fluent with the language, to not be surprised by its behavior. So let's talk about this. So let's start with the Boolean coercion. So first question is, which JavaScript values are Boolean coercible? And maybe let's also clarify what's a coercion. For example, if there's some method that expects you to pass the Boolean, it always in native JavaScript, it always will coerce it. I mean, if you don't provide type of Boolean directly, it will coerce it to some either true or false, yes? So now question is, for which values are coercible? So for which values this coercion won't crash? Are there any values like that for which will Boolean coercion crash? Are there any values in JavaScript? Like if you write if and just put a value, will it crash in any time? Yeah, that's correct. There are no values like this. Every value is Boolean coercible. Okay. Sorry about that, but I wanted to ask about that. So I hope not everyone is seeing it. So now, which values coerce to which Boolean? Do you have idea? No? Have you heard about false values? You for sure heard. So technically we should focus on false values because on those two coerce to false, because when we know which coerce to false, then we also know which coerce to true. And actually group of false values is very strict. So what are the false values in JavaScript? Undefined? null, 0, empty string, and there's, I think, one more. None. Yeah, that's correct. So now I can show it. Yes, and it's also obviously false, although it's already Boolean. I think it's also worth to mention, however, you don't have to know this and you can forget it right after I say it. There's one specific case in a JavaScript ecosystem, not directly in ECMAScript, but in DOM, that there was at some point introduced other object value which was made falsy. And this is very horror part of JavaScript. Thankfully, this object is deprecated and you should not use it at all. Do you know what's this?
Document all?
That's correct. That's correct. Yes. So if you wonder why they did it that way, it goes down to the IE Netscape war era, where IE implemented document all and Netscape didn't implement it at all. And after all, the other browsers also wanted to provide document all, but it appeared that existing application break because they go into IE mode. So they decided, okay, we can't just ship it like that, so we're going to make a type of return undefined and we're going to make it falsy. And really, this sounds really horrible. And thankfully, this object is deprecated, and it's extremely unlikely you will deal with it today, so it's okay if you forgot it now. Okay, so, sorry? Which one do you think I miss? No, it's an object. Yes, it will always be truthy. Always be truthy. So yes, everything else corresponds to true. And for reference, for future slides, I just put like simple to Boolean coercion, how it looks inside. Okay. Let's go further. Now, string coercion. So again, if any native JavaScript function takes string, actually, if it doesn't receive directly string, it will coerce to string. And question is, which values are string coercible? On which values that method won't crash? Are there any non-coercible values to string in JavaScript? They are coercible. If you pass undefined, you get undefined string. That's a bit crazy, but that's how it works. Yeah, so I'd say that nearly every value is string coercible. Nearly every. And specification doesn't define any object that is not string coercible, but we can create our own. So this is how you would see a simplified coercion algorithm. So you see undefined is a coerced to undefined string, null is coerced to null string, and for everything else there's a toString method. So now out of that, can you say which values are non-string coercible? Sorry? None is a number and has toString method. Sorry? But how would you create such value that doesn't have toString method?
The value could be in an object. On the prototype, I would write the function to
You
string.
can like, you mean like I will destroy, for example, toString on the prototype and, for example, like this?
For example.
Yeah, that's kind of, we can malform. For example, we can remove toString or make it crash or not return a string. It will make them not coercible. But there's more like valid example. This is that we are free in ECMAScript, sorry, that is in the bottom, to create non-coercible value via object create null. This creates kind of object with no prototype, and no prototype means there's no toString method. All other objects inherit from object prototype and has toString method. So this is the way where we can really deal with non-coercible string values. Okay, let's go to number coercion. So it's the same question: which numbers are coercible or maybe non-coercible numbers? On which values the coercion will crash? We have some native JavaScript method like mathmax, let's say, and on which values it will crash? So it's similar with the string. Nearly every value is number coercible. We need to here understand clearly that none is also from the number group. Although it's to say you can't have a valued number representation from this computation, it's technically type of a number and part of the number. So yes, so here when we say nearly every value, it means that there are some value that will crash coercion. Let's see what's this. So this is the simplified coercion algorithm. And yes, undefined coerces to none. Null coerces to 0. This is a kind of weird. I don't like it that much. I'm not sure why null also doesn't coerce to none. But maybe my colleague in my work told me that maybe it's related to C language, which they don't have any kind of a non-value type. And in case of null, they return 0. So maybe they wanted to kind of map this. I don't know. Yeah, the others are like booleans are 1 or 0. String has some specific coercion, but it can be put simply as that if it looks like a number, it will be this number. Otherwise, it's none. Number is number. It's interesting that they put symbol, that they made symbol non-coercible and not return none. I asked on some forum why is that, and so far I didn't receive any interesting answer why they did it that way. Yes, and in case of objects, it's usually the implementation try to take a primitive for using value of, and it didn't receive primitive, then it just uses toString and coerces the string to the number. So that's how it works. So we can say that non-coercible values are symbols and those which do not have primitive returning value of and do not have toString. So like that. Let's move further. So now I spoke about three coercion algorithms, number, boolean, and string. And I would like to stop for a moment on implicit coercion that happens in operators. So it's very important to understand that in JavaScript, operators are destined to, computation-based operators are destined only to work with the primitive string, booleans, or numbers. And that implicit coercion takes place. There are no dedicated operators, for example, addition of arrays, like objects or merging objects. So this is confusing for many developers coming from the other languages. When they add two arrays, expect some concatenation, and they receive empty string. They don't understand why it happens. They feel it's nonsense. There was also interesting presentation, very funny. Have you seen this? That exactly the guy over there plays with objects and uses operators that are distinct for the primitives. So yeah, so that's very important to acknowledge when you work with JavaScript. Every time you put some values to those operators, they are coerced to either boolean, numbers, or strings, and then the result is calculated into one of those types. Yeah. So I put short table how it works. So understanding that will make you less surprised when you see some strange value out of adding or I don't know, some mathematical operation. Yeah. Okay. So now we can go back to the last coercion that happens in the language is object coercion. So again, whenever any native function takes an object, there's a coercion. So now, which values are object coercible? For which values it will crash, and for which not? Technically, all values are coercible except non-values. So we can't use null or undefined. It may be confusing for some as they see the object constructor actually returning new object, but this object constructor doesn't reflect directly the object coercion over there. So everything for primitives you'll have object representation, and for the others are obviously the objects, so you will receive just those objects back. So that's how it works. It's interesting that we are not, if you know symbols, we are not allowed to use new symbol to create like object representation direct way, but if you use this object constructor, we can receive the object representation of a symbol. I'm not sure why they did it that way, but it's like that. It's kind of slight inconsistency, I think. Okay, yeah, non-coercible are null and undefined. So now we're gonna go from coercion to the duck typing because now we deal with the object. So whenever in any native ECMAScript JavaScript function expects an array, what it really expects? It doesn't expect necessarily to be instance of array. So do you have idea what what it does? Yes, so any object cursible value is accepted. So you can even put 0, because then it will internally be cursed to object. And then there's a number coercion on length string, which is also very forgiving. I will show you later. So, and even here I just show that I created a dummy array-like object here, and you can see that I can use all array methods on this, and I can even do mutation methods, which will work. For example, they will delete something from this array. And important to point, indexes or arrays are technically object properties. There's nothing like, oh, numeric indexes and object properties. It's same. It's quite important to understand when we work with arrays. So now, how would you state, for example, if this array will be consumable for any native method that expects an array? Yeah, so this is what I mentioned. It's any object cursible value with cursible length. This coercion is also very forgiving. If there's some nonsense like negative length, it will be just 0. If there's a none, it will be just 0. If it reaches over max safe integer, the implementation will say, hey, okay, it's a max integer then. Eventually it's also rounded to integers. It's very, very forgiving. And that's why technically you can do some nonsense operation like call array methods on some numbers. It will do nothing, but it won't crash. Yeah, so if you want to say like natively what can be consumed as array-like, we can go just to conclusion anything that's not a null or undefined. Just kind of weird, but in our APIs, I would recommend to also, in such case, check that length is numeric property. Because for sure, if someone sends us that doesn't have this, there's some error. We can totally assume this. Okay. So array-likes are from, I think, nearly the beginning of ECMAScript, and recently there are new protocols introduced with their recent version of the ECMAScript that provide some I think better, more also more low-level list handling. There are iterable and iterators. Are you familiar a bit with this, like set maps? You know, set maps share this, but iterable and iterator is good also in that case that technically we can create infinite collections. Like because every value iterator can be lazily resolved. Or for example, we can create a function that calculates iterator that calculates prime numbers. Like every time we want, we take the next one, and it's not that it needs to be finite. Yes. So yeah. So iterable protocol. So on any object, we can have a simple iterator method, which is expected to object of the iterator protocol. This is what is shared by set and map, and all the ECMAScript natives array arguments strings will also upgrade it to share that protocol. So you will have the simple iterator method that will return some kind of iterator. Now, what's an iterator protocol? Iterator protocol, so one that's returned by that simple iterator method, is about object that just expose a next method. And this is like very low-level way of iterating over list. Sorry, it's very down. You will have a link later to this presentation. But technically, when you receive an iterator, you need to iteratively call its next method, and you will see information, whether you already reached the end, and the next value. After the last value, the next call will tell you that is it. So, and there's a dedicated for-off statement in latest ECMAScript to iterate over iterators. And this is all objects that comply to those protocol or to iterable protocol are iterable with this. This is the simple rule as that. There's nothing more behind this. Yes. So what I also mentioned that all ES5 native types were upgraded to share also iterable protocol. They already are likes, and now they are also iterables. But also ECMAScript 2015 introduced new types like set and map, iterable types, and they are not RL-likes, and for valid reasons they are not RL-likes. They just share iterable protocol. Yeah, so there's now, with the new version of the language, we deal with the two list protocols, not perfectly compliant. We have also methods that work strictly with RL-likes, and we have methods that work strictly with arable. It's slightly problematic, and I think confusing might be for the future if you want to work really, build generic APIs. So, yeah, that's what I said, that there you have RL-likes and iterables. So, are you aware of also newly introduced method that help us to deal with them both cleanly? Are you familiar a bit with the ECMAScript 6 2015 specification?
Who is familiar? Hands up.
Who is familiar a bit with this? Okay, have you heard of RI from? Yeah, so RI from is technically the bridge for this, because RI from is a thing that takes either RI-like, it doesn't have to be iterable, or iterable, and it will return you an object which is both RI-like and iterable, and that object is RI. So with RI from, you can take, if you, for example, now you're writing some generic APIs and you want to accept any kind of lists, because you want to be, for many broad use cases you are writing this, then it's good to use RI from, as then you are friends with iterable protocol and you are friends with RI-like protocol. There's also other convenience that RI map also also allows you to iterate already on this object and map it to some already like slightly different map of values. Okay. The other duck typing type, promise. Do you know promises? Yeah, but you're familiar. Okay. So not sure if you are aware, but native promises also totally are based on duck typing. Any native method that expects a promise doesn't necessarily need native promise. All it needs is an object that extends a then method. And here I put an example of some nonsense promise object that works with native promises. And this one made on a very big purpose. You know that native implementation came after we have already very popular other libraries. It was very important that this native application is composable with the other implementation. It was also the goal of the Promise A+ movement to really have different libraries composable. So it was already goal there to use duck typing. So thanks to this, we can combine like Bluebird promises with native promises, and it will work. Just like that. Okay. And what about other things? There's no really duck typing, no other like duck typing example like that, the one I mentioned. But how then internally the detection of type works in ECMAScript methods? Do you know? We may say that internally it's also kind of based on duck typing because it actually, they are recognized by some internal slots. They don't have to be technically returned true for instance of operation for some type. They need to have some internal slot, but those internal slots are given to objects only when they are created using native constructors. That's why, for example, we cannot create something that will be understood as date if we don't do new date, if we don't create it that way. Like here I try to, some way to create something that may be perceived as a date-like, but no, it will crash. Yeah, still new implementation, there's like official specified way to change the prototype, and that way you can get something close to like date-like objects or regex-like objects, so objects that were you created using new constructor, but you switch the prototype of them. They're not instance, like for example, you can create date that's not instance of date, but will work with date native methods. Still, it's not seen that the last sentence, it's not a recommended practice really. It's very rare and very low level cases when you might want to change prototype of something, so you won't meet it really in that much in the libraries or anything. So you don't have to worry now that you will deal with dates that don't have methods, for example, common date methods. As for the last slide, I just wanted to also mention like a side case of callable because in some browser engines, older engines, there was a case of objects that were not instance of a function, didn't have call, bind, apply, but were actually callable. Technically, those objects were created as I shown on the other slide. I mean, you can understand them as created like that. So created as a function, but then with prototype being something else. So they're callable, although they are not really function. Like old version of Safari, I think it's no longer a case. The child knows, you could also get the knows using, parents, like on a function, which was slightly weird. Wars was in even older engines when, for example, those objects didn't return that they are type of function. So detection of such callable was more hard, but luckily we are past that. We don't have to worry. It's really old engines. IE8 is the last mark on this. So now I'm not aware of any callables like that in native APIs, but I'm not also 100% positive that there isn't. Okay, so I hope it helped you a bit organize your knowledge about the language. Okay, so thank you very much.